Spectro Analytical Labs Limited, has grown steadily in the last 17 years to become India's foremost analytical testing laboratory. The central laboratory is located in Ukla industrial area with an area of 28,000 square feet. Spectro Labs is equipped with the most sophisticated instruments and is supported by experienced group of professionals. Spectro provides complete testing and calibration solutions under one roof for chemical, biological, mechanical, non-destructive testing of variety of materials. It is the only lab in this part of country which is ISO 17025 accredited and NABLE accreditation in 5 fields, that is chemical, mechanical, biological, and DET and calibration. It is a multidisciplinary testing laboratory which undertakes testing of engineering materials, metals, polymers, ceramics, glass, textile, food, environmental, microbiological, petroleum, fertilizer, building material, water and soil etc., including calibration, preventive and corrective maintenance of measuring instruments, with an endeavor to develop technologically advanced, user-friendly, cost-effective indigenous high-end analytical equipments. Spectro Group has come up with an in-house R&D center which is dedicated to research, development, engineering, manufacturing, and commercialization of analytical testing instruments. Spread on an area of 2,000 square feet inside the Spectro premises in Ukla, New Delhi, the R&D center is staffed with a group of dedicated professionals who combine decades of knowledge to provide customized solutions to the unique development need in the field of Spectro R&D center cum automation lab. Our aim is to provide an end-to-end solution for automatic, user-friendly and cost-effective alternative to existing imported instruments. Spectro mainly focuses on software and application development for high-end analytical instruments which is being put to use in the field of material testing and certification. The R&D Center envisions developing equipments based upon latest software which keeps the product upgraded. Our goal is to provide right virtual instrumentation solutions through a combination of process knowledge, technical expertise and a reliable quality framework to create new and improved products and processes to meet market requirements. The team believes and works on constant revitalization of knowledge and expertise, for the development of new and improved products with an improved operational process to meet the changing social and environment needs along with meeting the requirements of customers at a lower cost. It is our constant goal to undertake research, develop and implement an advanced technology solution that resolves complex industrial automation problems. The main line of our research stands out for the development of automatic industrial solutions and services for testing of analytical parameters. Currently, the center is working on the research and development of oxygen calorimeter used in petrochemicals, food and power industry. Also known as bomb calorimeter, it is used for the determination of gross calorific value of combustible fuels. The result obtained by this technique helps in the rating of the fuel and allows the user to make certain important quality physiological, physical and financial decisions related to the fuel. The available automatic options for this instrument in market are mostly designed and manufactured by foreign organizations. Spectro is the first indigenous organization to have conceptualized and developed the instrument in India. Our team has worked upon the design and development of a precise and cost-effective alternative to the highly priced imported oxygen calorimeter. The instrument is supported by a dedicated flexible software which uses 24-bit 500 kilo samples per second data acquisition system. The closed-loop operation with water handling system helps in fast operation. The instrument is equipped with USB communication ports for reporting of results. The instrument is capable of being interfaced with analytical balance for automatic weight transfer and a printer. The instrument is a microprocessor-controlled isoperible oxygen bomb calorimeter which is widely used for calorific tests. It is a compact, integrated and benchtop laboratory model designed as per national and international standards. Particulate matter 2.5 sampler for environmental monitoring. Fine particulate sampler is used to determine the concentration of particulate matter of size less than 2.5 micron in atmosphere. A monitoring method has been designed which complies with the existing referral method. The system used is low cost since it makes use of basic industrial instruments. Since the available models are very expensive, this technology can be employed to develop an economical EPA-based system affordable for developing as well as underdeveloped nations. The sampler is designed according to US EPA 40 CFR 50 Appendix L. The top plate and wind deflector have been designed at a sampling flow rate of 16.67 liters per minute and unaffected by wind direction and wind speed of ambient air. The system includes a common PID controller, AC drive and a simple PC. The entire data is logged onto a PC and a host supervisory control, as well as data acquisition system analyzes the data. The advantage of using a PC is that it can not only analyze the data and generate the report on a custom format but also facilitates data transport via emails as well as wireless systems of GSM networking. The system used is low cost since it makes use of basic industrial instruments. The system can simultaneously use to measure noise level and level of gases. Timing and control system will maintain local time and date, including year, month, day of month, hour, minute, and second. The sampler shall be capable of starting the sample collection period and stopping the sample airflow and terminating the sampler collection period 24 later, or as specified by operator. The sampler have mechanical, electrical, or electronic controls for flow rate measurement and control, temperature control, data storage and computation, operator interface, and other functions specified. Salt spray corrosion test chamber. Salt spray test is a standardized test method used to check corrosion resistance of a product, which allows to inspect the degree of protection afforded by both inorganic and organic coatings on a metallic substrate. The results of the test can be used for the development of new metallic coatings, new paint coatings, as well as miscellaneous types of chemical treatments and paint pretreatments. Spectro has worked upon the design and features of the existing salt spray test chamber, which is already our product line, to develop cyclic corrosion test chamber, keeping in mind the fact that the automotive as well as other industries which makes use of this chamber can perform a variety of tests to simulate the effects of various environmental conditions on components and finished products, including gaseous atmosphere. This method is intended to provide a more realistic simulation of the interaction of factors than is found in traditional tests with continuous exposure to a static set of corrosive conditions. The maximum transition times between each part of the test cycle can be programmed through our user-friendly program to meet the industrial standards. Our teams of engineers are working on different softwares and hardwares to create the multiple options and to look for the most efficient and cost-effective alternative. Currently the team is working on different hardwares like embedded system and programmable logic controller to derive the most market-friendly product. We are working on hardwares from organizations like National Instruments to yield the desired output in a cost-effective manner. Spectro Research and Development Team has come up with a stress relaxation test machine that complies to IS 14268, 1995. Stress relaxation data can be used to develop stress relief heat treatments for reducing residual stresses and for the design of mechanical components like joints, gaskets, and springs. Stress relaxation data are also an important tool for evaluating the constitutive relations governing a material's inelastic behavior. The test developed by the team provides automatic real-time graph of residual stress versus time and temperature versus time, including automatic calculation of 1000-hour stress relaxation rate of the specimen. The test method has double logarithm and single logarithm option, selectable constant load and constant displacement control, automatic calculation of stress relaxation property of the specimen and printout of complete test report and test curves, realization of digital calibration of load quickly and accurately in addition to overload protection function. The test requirements can be automatically stored. The programming of the instruments is carried out by using programmable logic controllers and other related automation softwares, which are specialties of the group. One of the group's strong points is the design of quality system for the inspection, with the aim of developing robust industrial equipment capable for automatically performing quality control and validation of the product. This helps us to reduce the cost at the same time guaranteeing product quality. This involves the calibration of the sensors which are being used, testing of the material used for the mechanical designing of the instrument including hydraulic testing of the pipes and inspection of the endurance of the raw material as well as the finished goods and accessories. In addition, we continually evaluate our existing technologies, areas of ongoing research, and key learnings from our markets to identify opportunities to leverage that knowledge for the development of breakthrough solutions and keystone components for life-changing products. RefoQC Test System. The RefoQC Test System is a proprietary product developed after years of research and development. The system comprises many combinations of hardware and software depending upon design and custom requirements. The earlier systems were not capable to carry out online calculations, like standard deviation, uncertainty in measurement etc. The accuracy of measurement was limited to very coarse values and generally unacceptable as per NABLE guidelines. They used to imply different software and hardware to monitor energy and temperature separately using different standards and protocols having no facility of expansion or modification. The earlier systems were hardware dependent, so the cost of investment had limited life. The software made in most of the laboratories were in closed architecture, hence not offering flexibility in changing test requirements. The system designed by our team is capable to use any standard hardware to suit any budget. We have installed our systems at various industrial locations all over India. Our ongoing work involves conversion of universal testing machine into fatigue testing machine. A universal testing machine is used to test the tensile stress and compressive strength of materials. Fatigue testing is conducted to assess withstandability of materials against continuous exposure to loading and unloading up to specified fatigue strength. The universal testing machine can be converted into cyclic or fatigue testing machine to apply cyclic loads on test specimens. The fatigue testing machine can be used to simulate fatigue on a component or material to study its behavior under real-life load or stress conditions. The machine after conversion can be used to measure tensile stress, compressive stress, bending and torsion stress as per the original capability of the machine. The machine is most suitable to test springs, suspension components, biomedical implants and metal structural components. The entire process can be converted into fully automated or partly automated depending upon the custom requirement and feasibility. The center also focuses on the upcoming environmental safety issues and conducts survey on various environmental concerns pertaining to water pollution monitoring, air pollution monitoring, noise pollution monitoring, waste management, baseline data generation for air and other related analysis. Some of the projects which Spectro have dealt with are survey of municipal solid waste, monitoring of ambient air, water quality, stack emission and drinking water quality parameters, water quality monitoring and flow measurements, environmental monitoring at refineries, power plants, automobile industries etc. testing of industrial effluents and emissions, testing of air quality and noise pollution,